Okay, so the dot product of two vectors in Rn is defined, I'm going to define it as this. Express one vector as a row, the other vector as a column. The dot product is what you get when you multiply the row by the column. Demonstrate in a minute. Okay, vectors are orthogonal if and only if the dot product is 0. Okay? Now what do we mean by orthogonal? Well, as we're going to see, it's just a generalization of the concept of perpendicularity, okay, right angleness. But it goes into spaces where angle isn't necessarily defined, although it can be. So we want the concept of orthogonality. It's a great big deal. Matter of fact, I think most linear algebra texts have a whole chapter on orthogonality because it's so incredibly important. And it's very neat too. Okay, well, let's take the basis vector for your null space and the basis vector for your row space. Okay? The vector 2, 1, the basis of your row space, wherever I wrote it, actually it's not 2, 1, it's 1, 1/2. We'll choose to make this one the row, and we'll make this basis vector from the null space the column. Well, if I multiply this row by this column, I don't need a comma there, do I? If I multiply this row by this column, I get excuse me, 1 minus 1, which equals 0. Okay? Matter of fact, if I multiply any multiple of this vector by any multiple of this vector, I'm going to get the same thing. So let's just say I take a multiple C times 1, 1/2 row vector, T times the 1, -2. Well, that equals C over 2 times T -2T. That equals C times T plus C over 2 times -2T, which equals C times T minus C times T, which equals 0. So we're going to say then that the row space is orthogonal to the null space. Now that's identical to saying that they're perpendicular in R2. Okay? The row space is orthogonal to the null space. Now what about the column space? Does it have any relation to the row space and null space? Well, it has a relationship, but it's not orthogonal. If you take the 1, 1/2 vector times the 4, -6 vector, you get 4 minus 3, which is 1. It's certainly not orthogonal to the row space. And if you do the same thing with the column space, it's even less orthogonal. Matter of fact, it's more or less in the same direction, but not exactly. Okay, well, there's more that could be said, but we want to get the picture of a row space and a null space being orthogonal. Okay? And then we want to get the picture of the mapping of V to W. Okay, well, I'm going to draw, well, let me just draw it here. Okay. So here's V. And here's W. We have a row space, and we have an orthogonal null space. Always orthogonal. Okay? Now let me get a little bit colorful. Okay. I'm going to make the null space yellow, and I'm going to indicate that the null space consists of all the vectors that get taken to 0. So the image of every vector in the null space is 0. So the image of every vector on this null space, the entire null space, every point here being defining a vector. Every one of these goes all the way to the 0 vector. I didn't make them all go, things get a little crowded in there around the 0 vector, but we understand what I'm saying. The null space maps to the 0 vector. The row space, on the other hand, maps to the column space. So if I grab another color and make the column space purple, okay, so I'm just going to draw one arrow, but every point here goes to some point over here. This point doesn't necessarily go to this point, but I'm just indicating that this entire line maps onto this line, in the sense, again, that every point in this line corresponds to a vector, and that vector maps to a vector whose initial point being on the origin, the terminal point will be on this line. Okay, so the row space maps to the column space. And null space maps to the 0 vector. Now what about vectors that are defined by other points? Because we don't have the entire plane on this line and this line. There's a whole lot of plane there. Matter of fact, we haven't taken any area out of the plane by grabbing these two lines, because the lines don't have any area, but the plane certainly does. There's a whole lot more plane, in other words, than there is null space and column space, and row space, I'm sorry. So what are we going to do about all the other possible vectors? Well, we'll look at that in a minute.